This is 2019 August past paper question, Combined Maths 2. A system consists of three forces in the plane of a regular hexagon ABCDEF of center O and side of length 2A. Forces and their points of action in the usual notation are shown in the table below with the origin O. The OX axis along OB and the OY axis along OH, where H is the midpoint of CD. P is measured in newtons and A is measured in meter. One of the table, 3 points A, C, E, and these point position vectors are given. At these points A, this force acting 3pi plus root 3pj, and at point C, the force minus 3pi plus root 3pj, and at point E, the force minus 2 root 3pj is acting. Show that the system is equivalent to a couple and the moment of the couple, and find the moment of the couple. Now an additional force of magnitude 6p Newton acting along FE is introduced to the system. Find the magnitude, direction and the line of action of the single force to which the new system produce. Answer for this question. One of the hexagon side 2A, hexagon ABCDEF, and H is the midpoint of CD. OX axis and OY axis. Along the OX axis, I is the unit vector. Along the OY axis, J is the unit vector. This is 60 degree, and the position vector of point A, this one, point A, AI minus root 3AJ. So this point A, coordinate A, minus root 3A. This one. This point coordinate. And position vector of C, AI plus root 3AJ. The coordinate of point C, A, root 3A. Position vector of E minus 2AI. Therefore, coordinates of this point E minus 2A, 0. And the force at point A in the I direction along the unit vector I, 3P, and along the unit vector J, root 3P. So in the x-axis 3P and in the y-axis root 3P. And other force, this one, along the I direction minus 3P, along the J direction, root 3P. In the I direction minus 3P, or we can say opposite to the I direction 3P. Both are same. Along the I direction minus 3p, opposite to the I direction 3p. And at the point E, minus 2 root 3 pj. Along the I direction, no pose. The j direction, in the unit vector j direction, minus 2 root 3p. Minus 2 root 3p. Minus 2 root 3p. Oh, opposite to the j direction, we can put like this one, 2 root 3p. Or this one. The same meaning. Now, question, show that the system is equivalent to a couple and find the moment of the couple. Now, we must show that R is equal 0 and G not equal to 0. How to show the R is equal 0? The horizontal components of the force along the x-axis and along the y-axis. If two components are 0, then we can say R is equal 0. R is equal 0. Along the horizontal direction, let's say x, therefore x is equal 3p, this one minus 3p. 3p minus 3p, therefore x is equal 0. Along the y direction, root 3p, here root 3p, here root 3p, here root 3p, here minus 2 root 3p, opposite direction. Therefore, this is equal 0, y is equal 0. Now, x component 0, y component 0, therefore resultant R is equal 0. Take a moment about point O. That is G, and 2 root 3p in this direction, right hand side, 2 root 3p into this direction, this distance, moment goes into distance. This distance 2a, there 2 root 3p into 2a, plus here 3p into the distance from here to here, this distance. This distance is a 2a 60, there 2a sine 60, 3p into 2a sine 60, plus root 3p into the distance, here to this distance, or might be this distance. This is a 2a, this is a midpoint, no, this is an a. Therefore, root 3p into a. Plus 3p into, we can say 3p because in this direction minus 3p, or we can say like this one, 3p into this distance to a sine 60. And plus root 3p into, for this one, the distance from here to here is an 8. Root 3p into 8. When we simplify this one, 2 root 3 into 2 4 root 3 PA. For this one root 3 PA, 5 root 3 PA, Saga 1 root 3 PA, therefore 6 root 3 PA. This one 2 into 3, 6 PA sine 60. Here also 6 PA sine 60, therefore 12 PA sine 60. 6 root 3 PA plus 12 PA into sine 60 root 3 by 2, 6 root 3 PA plus this one also 6 root 3 PA. Therefore, G is equal 12 root 3 PA. This one not equal to 0. Therefore, the system R is equal to 0, G not equal to 0. Is a 12 root 3 PA Newton. Therefore, R is equal to 0 and G not equal to 0. The system of forces reduced to a couple. Moment of this couple is a G, magnitude of 12 root 3 PA. Next part. One of the new force is introducing a 6p Newton along the FE direction. New force 6p Newton acting along FE. Over here I will mention already this system is equivalent to G. Already this system is equivalent to G. Resultant is a 0. Now we introduce 6p Newton along FE. This one 6p Newton we introduce here. Now there is only a force 6p and a couple having moment G. But in our theory we learned, the system be reduced further only a single force 6p at a distance G over 6p from point F. Coupled and the force also can be further reduced to a single force by shifting by a distance. Therefore, this G and P can be reduced further only a single force without G, but the force is shifted at a distance G over 6p. In our theory we learned. Therefore, this system can be reduced to a further a single force like this one. But now this force is shifted G over 6p. Previous like this one, couple of couples and the force now can be reduced further like this one. Now only force 6p shifted the distance, this distance G over 6p. Now we will find out the distance, this FL G over 6p. FL G over 6p. We don't know. We don't know where it would be. Okay, now for G already we know 12 root 3 PA over 6p. Therefore, FL is 2 root 3a. Let this the equation number 1. FL, this point L can be anywhere in this slide. This is one of the certain instance. What is the distance FB in the hexagon? In the hexagon, what is the distance FB? This one 2a, this one 2a, this one 30 degree. Therefore, FB is equal 2a cos 30 plus 2a cos 30. So 4a cos 30. This one 4a into root 3 by 2. This one 2 root 3a. FB is a 2 root 3a. FB distance also 2 root 3a. But FL also 2 root 3a here. 1 and 2. What can we say? Compare the distance FL and FB. Here FL 2 root 3a. FB 2 root 3a. Then what is the relationship FL and FB? FL is equal FB. Or FL is equal FB. Therefore, FL is equal FB means L might be here. Therefore, this 6p Newton acting along BC. 6p Newton, the single force acting along BC. This is the line of action BC. Therefore, the single force 6p acts along the direction BC. Magnitude 6p, line of action BC, and the direction B to C. The question. Find the magnitude 6p, direction B to C, and line of action BC.